From the time you were small, you were handed the same promise about the night sky. It is enormous, and it is full, and one day, with enough time and enough cleverness, it could be ours to cross. But here is what that promise left out. The universe is not waiting for us. It is expanding, and the expansion is speeding up, and that single fact quietly rewrites everything. Right now, more than 97% of the galaxies you can see are already beyond any signal we could ever send, not too far. Beyond reach forever, the way yesterday is beyond reach. There are 2 trillion galaxies in our sky, and we are forbidden from ever touching all but a tiny handful of them. Every second, more of them cross a line called the cosmic event horizon and are lost for good, carried off by growing space faster than light itself can chase them. The universe is full of company, and it is quietly sealing us away from all of it. Get comfortable. Hit subscribe if you're new here, because by the end of this, the night sky will look less like an open ocean and more like a window that is slowly, gently closing. Now, let's slowly ease into this. Part 1. The Ocean We Were Promised. Somewhere out there, tonight, is a galaxy you will never reach. Not because it is too far for our ships, though it is. Not because the journey would take too long, though it would. You will never reach it because the universe itself has already decided the matter, quietly and without cruelty, and the decision is final. That galaxy is leaving, and the road between you and it is lengthening faster than anything you could ever send across it. You can look at its light. You cannot follow it home. We do not usually think about the universe this way. From the time we are children, we are handed a picture of the cosmos as a kind of endless ocean, and we are told, gently, that it is ours. We are told that the night sky is full of places, that the stars are suns, that around those suns are worlds, and that the only thing standing between us and all of it is distance and patience and cleverness. The story we inherit is a story of frontiers. It says that the universe is large, but large in the way an unexplored continent is large. Difficult, yes. Slow, certainly, but open, waiting. The kind of thing a long enough effort could eventually cross. That picture is one of the most comforting ideas human beings have ever held, and tonight we are going to take it apart. Not to frighten you, and not because the truth is bleak, but because the truth is stranger and more beautiful than the comfortable version, and because the real shape of our situation is something almost no one is taught. The universe is not a fixed ocean waiting to be sailed. It is an ocean that is pulling itself apart in every direction at once, and the farther a shore lies from you, the faster it is fleeing. Beyond a certain point, the water itself moves away from you faster than any boat could ever travel, and the far shores are not merely distant. They are gone in the most permanent sense the word can carry, while their light still arrives to tell you they were ever there at all. Let us begin with the scale we think we own, because the loss only makes sense once you feel the size of the thing being lost. When you look up on a clear night, far from city lights, you can see a few thousand stars with the naked eye. Every single one of them belongs to our own galaxy, the Milky Way, a turning wheel of several 100 billion stars. That alone is a number the mind cannot truly hold. If you tried to count the stars in our galaxy at a rate of 1 per second, never sleeping, never stopping, you would need something close to 10,000 years to finish. And our galaxy is one, just one. Point a good telescope at what looks like an empty patch of sky, a patch the size of a grain of sand, held at arm's length, and hold it there. This is more or less what astronomers did with the Hubble Space Telescope in a now famous series of long exposures, staring at a piece of darkness that seemed to contain nothing at all. What came back was not nothing. What came back was thousands of galaxies crowded into that single dark speck, each one a city of billions of stars, some of them so distant that their light had been traveling toward us for most of the age of the universe. Every direction you look, the same thing is true. The darkness between the stars is not empty. It is packed with galaxies, layer behind layer, as far as our instruments can see. When astronomers add it all up, when they take those long exposure images and multiply outward to cover the whole sky and the whole reach of their telescopes, they arrive at a number that has no business feeling real. The observable universe, the part we can see, appears to contain something on the order of 2 trillion galaxies, not 2 trillion stars. 2 trillion galaxies, each one holding stars by the hundreds of billions. The arithmetic spirals past anything our intuition can grip. The number of stars in the visible universe is larger than the number of grains of sand on every beach and in every desert on Earth, by a margin that is itself difficult to state. So here is the ocean we were promised. 2 trillion galaxies, an expanse so enormous that we have to invent new ways of writing numbers just to talk about it. And the natural feeling, the feeling almost everyone has when they first really absorb that scale, is a kind of soaring optimism. Look how much there is. Look how far it goes. Surely, in all of that, we are not meant to be small and stranded. Surely a universe this generous with worlds is a universe that wants to be explored. The sheer abundance feels like an invitation. Hold on to that feeling, because it is exactly the feeling this video is going to complicate. The abundance is real. Every one of those galaxies is really out there. But the invitation is the part that is not true, and the reason it is not true is the single most important fact about the universe you live in, a fact discovered within living memory and still not widely understood. The universe is not sitting still and waiting. It is expanding, and it is not just expanding, the expansion is speeding up. Those two sentences sound mild. They sound like the kind of thing you half remember from a documentary, a piece of cosmic trivia that does not seem to bear on your life. But follow them far enough, with enough honesty, and they lead somewhere that changes the meaning of every one of those 2 trillion galaxies. They lead to the conclusion that the overwhelming majority of the universe we can see is already, permanently, beyond our reach. Not hard to reach, not reachable only with technology we do not yet have. Beyond reach in the way that yesterday is beyond reach, sealed off by the geometry of space itself. This is the quiet engine of everything we are going to talk about tonight, so let me state it as plainly as I can before we earn it slowly together. There is a line drawn around us in space. Inside that line are the things we could still, in principle, touch, signal, or visit, if we had unlimited time and unlimited capability. Outside that line is everything else, and everything else is most of the universe. The line has a name. Astronomers call it the cosmic event horizon, and it behaves like the surface of a black hole turned inside out. We are not falling into it. The rest of the universe is falling out through it, one galaxy at a time, forever. And here is the part that makes this more than a lecture about cosmology. The same force that draws that line, the same property of space that seals us in, may also be one of the reasons we are here at all. The number responsible for our isolation appears to sit inside an almost impossibly narrow window, a window that also happens to be the window that allowed galaxies and stars and planets, and, eventually, you, to exist. A universe slightly different in this one quantity would never have isolated us, because it would never have let us form in the first place. So we are left with a coincidence that has unsettled some of the finest minds in physics. The universe seems built to keep us alone, and the word seems, as we will see by the end, is the most loaded and most honest word in all of cosmology. The universe is not pushing us away out of malice. I want you to remember that sentence, because we are going to return to it, and it will mean something different when we do. There is no hand on the other galaxies, shoving them toward the dark. There is only space, growing everywhere, gently and relentlessly, doing to every observer in the cosmos exactly what it is doing to us. We are not being singled out. We are simply learning, a little earlier than most, what it means to live in a universe that expands. So settle in and let us start where the trouble starts, with a discovery that seemed at first like nothing more than a careful measurement of light from distant stars, and turned out to be the moment we found out the ocean was draining. Part 2. Everything is running away. The first crack in the comfortable picture appeared almost exactly 100 years ago, and it appeared in the color of light. To understand what isolates us, you have to understand this, because everything that follows grows from it. So let us take it slowly. Light carries information about the thing that made it, and one of the things it carries is motion. You already know this from sound, even if you have never thought of it that way. When an ambulance races toward you, its siren rises in pitch, and as it passes and speeds away, the pitch drops. The sound waves are getting bunched up as the source approaches and stretched out as it recedes. Light does the same thing. When a source of light moves away from you, the waves of that light get stretched, and stretching a light wave shifts its color toward the red end of the spectrum. Astronomers call this redshift. A galaxy moving away from us has its light reddened, and the faster it moves away, the more reddened it becomes. This is not a subtle laboratory effect. It is written plainly into the light of every distant galaxy, and it can be measured with great precision. In the 1910s and 1920s, astronomers began measuring the redshifts of the faint spiral smudges they could see in their telescopes, the objects we now know to be other galaxies. And they found something strange. Almost every one of them was redshifted. Almost every galaxy in the sky was moving away from us. This was peculiar on its own. If the galaxies were moving randomly, like gnats in a swarm, you would expect roughly half of them to be coming toward us. Their light shifted toward blue, and half moving away shifted toward red. Instead, nearly the entire sky was fleeing. Then came the measurement that changed the shape of the universe. Working at the Mount Wilson Observatory in California, the astronomer Edwin Hubble compared how far away each galaxy was with how fast it was receding. And he found a clean, simple relationship, one of the most consequential relationships ever discovered. The farther away a galaxy was, the faster it was moving away from us. Not randomly faster, proportionally faster. A galaxy twice as far away was receding twice as fast. A galaxy 10 times as far was receding 10 times as fast. The rule was so regular that you could write it as a single short line of arithmetic. The speed at which a galaxy recedes equals its distance multiplied by a fixed number, a number we now call the Hubble constant. Sit with how odd that is. Every galaxy, in every direction, fleeing from us, and the speed of the flight set precisely by the distance. There is a naive way to read this that is very flattering and completely wrong. The naive reading says, well, if everything is running away from us specifically, then we must be at the center of the universe, the still point at the middle of a grand explosion, with all the debris flying outward from where we stand. For a moment, that interpretation feels almost reasonable. It is also exactly backwards, and seeing why is the first real step toward understanding our isolation. Imagine a loaf of raisin bread rising in an oven. The dough is studded with raisins, scattered throughout, and as the dough bakes, it expands in every direction. Now pick any one raisin and imagine you are sitting on it, looking out at the others. As the loaf swells, every other raisin moves away from you, because the dough between you and each of them is growing. And here is the crucial part. A raisin that started out twice as far away has twice as much dough between it and you, so as that dough expands, it carries the far raisin away twice as fast. The relationship you would measure, sitting on your raisin, is exactly Hubble's relationship. The farther the raisin, the faster it recedes. And yet, there is no special raisin. There is no center. Every raisin sees exactly the same thing. Every raisin feels like the still point, with everything fleeing from it, and none of them is right. The expansion has no middle. It is happening everywhere, between everything all at once. That is what the redshifts were telling us. The galaxies are not flying through space away from some central blast. The space between the galaxies is growing. Each galaxy sits more or less still in its own patch of space, going about its business, while the distances between galaxies stretch like the dough in the rising loaf. We are not at the center of a great running away. There is no center. We are simply one raisin among trillions, watching the bread rise, and so is everyone else. This single idea, that space itself expands, is the foundation under everything we are building tonight, so let me make sure it is solid before we go on. When we say a distant galaxy is receding at some enormous speed, we do not mean it is hurtling through the cosmos like a thrown stone. We mean that the amount of space between us and it is increasing. The galaxy is barely moving relative to its own neighborhood. It is the road that is lengthening, not the traveler that is sprinting. This distinction is going to matter more and more as we go, because it is the difference between a problem you could solve with a fast enough ship and a problem no ship can ever solve. You can outrun a traveler, you cannot outrun a road that grows faster than you can run. Now, how fast does this growth actually happen? The Hubble constant, the number that sets the rate, has been measured many times and in many ways, and the answer comes out to roughly 70 kilometers per second for every megaparsec of distance. Let me translate that, because the units are unfamiliar. A megaparsec is about 3.25 million light-years, a distance so large that it comfortably spans the gaps between galaxies. And what the number says is this: for every one of those gulfs of 3.25 million light-years that lies between you and a distant galaxy, that galaxy recedes about 70 kilometers per second faster. One gulf away, 70 kilometers per second. 2 gulfs, 140. 10 gulfs, 700. The recession speed simply keeps climbing, adding 70 kilometers per second for every step outward, with no ceiling written into the rule. And that absence of a ceiling is where the story turns. Because if you keep stepping outward, adding 70 kilometers per second again and again, you eventually reach a distance where the recession speed equals the speed of light. And then you take one more step, and the recession speed exceeds it. The arithmetic does not stop politely at the cosmic speed limit. It just keeps adding. Somewhere out there, the rule says, are galaxies whose distance is so great that the space between us and them is growing faster than light itself can cross it. When most people hear that sentence for the first time, they assume it must be a mistake. Nothing travels faster than light. That is the one rule everybody knows, the iron law at the bottom of modern physics, the thing Einstein supposedly nailed shut forever. And it is true. Nothing travels through space faster than light. But the galaxies, receding faster than light, are not traveling through space. They are being carried apart by the growth of space, and that growth obeys no such limit. The rule against faster-than-light motion is a rule about objects moving from place to place. It says nothing about how fast new space can appear between two places that are barely moving at all. This is the single most counterintuitive idea in the whole subject, and it is the hinge on which our isolation turns. So in the next part, let us slow all the way down and look at it directly. Let us look at what it actually means that the universe is full of galaxies racing away from us faster than their own light can ever reach us, and why this does not break the laws of physics, and why it quietly breaks something we believed about the laws instead. Part 3. Faster than light itself. Let us go back to the rising loaf of bread, because it is about to teach us the strangest lesson in cosmology. Picture the dough expanding, the raisins drifting apart, each one watching the others recede. Now imagine the loaf is enormous, larger than any oven, and the dough is rising at a steady rate everywhere. Pick your raisin, the one you are sitting on, and look at a raisin very far away, near the distant edge of the loaf. Between you and that far raisin, there is an immense amount of dough, and every cubic inch of that dough is swelling. Add up all that swelling across all that distance, and the far raisin pulls away from you at a tremendous speed, even though it is not crawling across the dough at all. It is sitting still in its own little pocket. There is just so much growing dough between you that the sum of all that growth carries it away faster than you can imagine. Now make the loaf bigger still and pick a raisin even farther out. There is even more dough between you, even more total swelling, and so the recession is even faster. Keep going. There is no point at which the dough refuses to add up. And so, in a loaf large enough, there are raisins so distant that the dough between you and them is growing faster than you could ever travel across it, even at the highest speed you are allowed. If you were a beam of light setting out across that dough toward the far raisin, you would find that the road ahead of you was lengthening faster than you could cover it. You would run forever and never arrive. This is not a flaw in the metaphor. This is exactly what space does. The rule that nothing can exceed the speed of light is a rule about motion through space. It says that you cannot take an object and accelerate it through space past that limit. But the expansion of the universe is not motion through space. It is the creation of new space, everywhere, continuously. And when you add up the expansion across a great enough distance, the total recession can exceed the speed of light without any single thing ever moving through space faster than light is allowed to. No law is broken. The galaxy is not speeding. The space is simply growing. And there is so much of it between you and the galaxy that the growth outpaces light. I want to make sure this lands, because it overturns something most of us carry without realizing we carry it. Almost everyone grows up with a quiet, unspoken belief that light can eventually reach anywhere. It might take a long time. The distances might be enormous. But give a beam of light enough time, the belief says, and it will get there in the end, because light is the fastest thing there is, and the universe will hold still long enough for it to cross. That belief feels like bedrock. It feels like it could not possibly be wrong. It is wrong. The universe does not hold still. For galaxies beyond a certain distance, the space between us and them grows faster than light can traverse it, which means a beam of light leaving us now, aimed at one of those galaxies, will never arrive. Not in 1 trillion years. Not ever. The destination recedes faster than the light approaches, and the gap between them widens with every passing moment. The light is not slow. The light is doing everything it can. The road is simply winning. There is a specific distance where this transition happens, and astronomers have a name for it. They call it the Hubble radius, or the Hubble sphere, and it marks the distance at which the recession speed of the expanding universe equals the speed of light. Using the measured expansion rate, that distance works out to about 14.4 billion light-years. Inside that sphere, galaxies recede slower than light. Outside it, they recede faster. And the universe is absolutely full of galaxies outside it. The Hubble sphere is not some far frontier at the edge of everything. It sits well within the region we can see. Most of the galaxies in our telescopes lie beyond it, receding faster than light right now, as you listen to this. And here is a subtlety that catches even careful people, because it seems at first to contradict everything I have just said. If those galaxies are receding faster than light, how do we see them at all? How does their light ever reach us if the space between us is growing faster than the light can cross it? The answer is one of those beautiful, dizzying details that makes cosmology feel less like a science and more like a riddle. The light we see from those galaxies was emitted long ago, billions of years ago, when the universe was younger and the relevant distances were smaller and the geometry was different. That ancient light has been struggling toward us across expanding space the entire time. For some of it, near the beginning of its journey, the expansion was slow enough in the regions it crossed that it could make headway. Whether a given beam of light eventually reaches us depends on the entire history of expansion along its path, not just on how fast the source is receding today. So we live inside a strange double vision. We can see galaxies that are, at this very moment, receding from us faster than light, and whose present-day light will never reach us, because we are seeing only their ancient past, the light they sent when the situation was kinder. The galaxy we observe is a ghost, an image from billions of years ago. The galaxy as it is right now is already unreachable, already beyond the point where any new signal could ever pass between us. We are looking at a postcard from a place that no longer answers its mail. This is the first place where the comfortable picture truly cracks. So let me name the crack precisely. It is not that the universe is too big to cross. Bigness alone would not stop us, given enough patience. It is that the universe grows faster than we can cross it, and those are completely different kinds of obstacle. A big universe is a challenge. A growing universe is a wall. With a big universe, every mile you travel is a mile gained, and you make steady progress, however slow. With a growing universe beyond the Hubble sphere, every mile you travel toward a distant galaxy is more than matched by new miles appearing in front of you. You do not make progress. You lose ground while moving forward at the maximum speed reality permits. The destination does not get closer. It gets farther, no matter what you do. Think about what that means for the dream we started with, the dream of the open ocean. We imagined the universe as a frontier, difficult but crossable, the far shores merely distant. But the far shores are not merely distant. They are receding faster than light, which means they are not shores we have failed to reach yet. They are shores we are forbidden to reach by the structure of space itself, with a finality that has nothing to do with our technology or our patience or our will. The fastest ship imaginable, a ship that rode a beam of light, could not reach them. The expansion has already closed the door. And yet, I want to keep returning to this, because it matters for how the whole story feels. The universe is not pushing those galaxies away, out of malice. There is no force acting on them, no great wind blowing them into the dark. Each one sits quietly in its own region of space, no more moving than we are. The separation between us grows not because anything is being shoved, but because space everywhere is gently, ceaselessly enlarging. The galaxies are not running from us. They are being carried, as we are being carried, on a tide that lifts everything away from everything else. It is the most impersonal exile imaginable, and that impersonality, as we will see, is the closest thing to comfort the physics has to offer. So we have learned that the universe contains a horizon of speed, the Hubble sphere, beyond which things recede faster than light. But the Hubble sphere is not yet the true wall, because, as we just saw, we can still see and even still reach some things beyond it, thanks to the long history of light in transit. To find the real wall, the boundary of what we can ever touch, we have to look harder at the difference between two ideas we usually treat as the same, seeing a thing and reaching it. They are not the same thing at all. And the gap between them is the cruelest and most beautiful thing in this entire story. Part 4. The difference between seeing and reaching. There is a difference between a photograph of someone and the person themselves, and tonight that difference is the difference between two kinds of cosmic boundary. We tend to use the words seeing and reaching loosely, as if they were close cousins, as if anything you can see you could in principle get to. On Earth, that is roughly true. If you can see a mountain on the horizon, you can walk to it. The light that reached your eye travelled the same path you would travel, only faster. Seeing is a kind of promise of reaching. But in an expanding universe that promise dissolves, and the dissolving of it is the quiet tragedy at the centre of our situation. Let me give you the two boundaries. because keeping them separate is the whole game. The first boundary is the edge of what we can see. Astronomers call it the particle horizon, though you can just think of it as the edge of the observable universe. It marks the farthest distance from which light has had enough time to reach us since the universe began, roughly 13.8 billion years ago. Light from anything beyond that edge simply has not had time to get here yet. Now, you might think that since the universe is 13.8 billion years old, the edge of what we can see should be 13.8 billion light-years away. But it is not, because while that ancient light was traveling toward us, the space it had already crossed kept expanding, carrying its source ever farther away behind it. By the time the light arrives, the place that emitted it has been swept out to a distance of about 46.5 billion light-years. So the observable universe is a sphere around us, roughly 93 billion light-years across, far larger than its age alone would suggest. That is the edge of seeing. The second boundary is the edge of what we can reach, and it is a smaller, crueler circle drawn inside the first. Astronomers call it the cosmic event horizon. It marks the farthest distance to which a signal sent from us today, traveling at the speed of light, could ever arrive. Anything closer than this horizon, we could still in principle touch if we sent our message right now and waited long enough. Anything beyond it is sealed off. A beam of light we emit this instant, aimed at a galaxy past the event horizon, will chase it across expanding space forever and never close the gap. In our universe, this horizon sits at a distance of roughly 16 billion light-years. That is the edge of reaching. Now hold those two numbers side by side and feel the gap between them. The edge of seeing is about 46 billion light-years away. The edge of reaching is about 16 billion light-years away. Between those two boundaries lies an immense shell of the universe, light-years upon light-years of it, packed with galaxies that we can observe in exquisite detail and never, ever touch. We can photograph those galaxies. We can measure their colors, weigh their stars, read the chemistry of their gas, watch their supernovae flare and fade, and not one atom of us, not one photon we emit, not one whisper of any signal we could ever construct will reach a single one of them. They are visible and they are forbidden, both at once. You can see it, but you can never touch it. I want you to hold on to that sentence, because we are going to come back to it later in a way you will not expect, and when we do, it will have changed its meaning entirely. For now, let it sit in its simplest form. The light arrives, the meeting is impossible. The universe shows us a face it will not let us approach. There is something almost unbearably poignant in this, and it is worth letting yourself feel it rather than rushing past. Think about what it is to receive light from a galaxy you can never reach. That light left its home billions of years ago. It crossed an ocean of expanding space, the entire age of the Earth and longer. It threaded through the dark, untouched, carrying the image of a place teeming with stars, and at the very end of its impossibly long journey, it fell into the mirror of a telescope and gave itself up to us, so that we could know that place existed. And the place it shows us is already gone from our reach. The galaxy that sent that light has, in the time the light was traveling, been carried so far away that we could never answer it. It is as if you received a letter from someone, a long and beautiful letter, full of news and life, and the moment you finish reading it, you understood that the person who wrote it had passed beyond any possibility of reply. The letter is real. The connection it seems to offer is a connection that no longer exists. This is the emotional core of the whole topic, so let me say it as plainly as I can. The universe is not empty. That is the mistake people make when they first hear about cosmic loneliness. They picture a barren void, a few scattered lights in an ocean of nothing. But that is not our situation at all. Our situation is the opposite. The universe is full. It is crowded with galaxies, 2 trillion of them in the part we can see, brimming with stars and worlds, and, for all we know, with minds. We are not alone because the universe is empty. We are alone because the universe is full of company we are barred from ever reaching. The loneliness is not the loneliness of an empty room. It is the loneliness of a crowded city seen through a window that will not open, where you can watch the life go by, but never step outside, never speak to anyone, never be answered. And the window is not even staying the same size. This is the part that turns a melancholy fact into a moving one. The boundary of what we can reach is not fixed. As the expansion accelerates, the event horizon draws inward in the sense that matters most. Galaxies that are reachable today will not be reachable tomorrow. There is a redshift, a measure of how far a galaxy's light has been stretched, of about 1.7, and it marks a kind of point of no return. Galaxies whose light reaches us with a redshift greater than that are already beyond our event horizon. We can see them because their old light is still arriving, but any signal we send toward them now will never catch them. And every day, more galaxies cross that line. They slip from the category of things we could still in principle reach into the category of things we have lost forever, and they do it silently, while we are not watching, while we are asleep, while we are arguing about smaller matters. It helps to make this concrete. Imagine that the reachable universe is a territory drawn on a map, the territory of every place a message from us could ever go. That territory is not growing, it is shrinking. Around its edge, galaxy by galaxy, the boundary contracts, and each galaxy that crosses out is gone for good. There is no negotiating it back. There is no faster ship that retrieves it. Once a galaxy passes beyond the event horizon, the severance is as complete and as permanent as anything in physics. We will go on seeing its ancient light for ages, fading and reddening, a long goodbye written in stretched photons. But the thing itself has stepped outside our world and will never step back in. So we have found the true wall at last. It is not the edge of what we can see, which is wide and generous and full of light. It is the edge of what we can reach, which is narrower and tightening, and which divides the universe into the touchable few and the untouchable many. The comfortable picture promised us a frontier. What we have instead is a horizon that closes, and we have not even named the force that closes it. We have described the wall without naming the hand that builds it. In the next part, let us look at just how much has already been lost, and how fast the losing goes, and then we will finally name the thing responsible, the strangest and least understood substance in all of physics, the thing we call dark energy. Part 5. The Shrinking Map. Let us count what we have lost, calmly and exactly, because the numbers are the part that nobody believes until they sit with them. We have a universe we can see, 93 billion light-years across, holding something like 2 trillion galaxies. And we have a much smaller region we can actually reach, bounded by the event horizon at about 16 billion light-years. The question is simple. Of everything we can see, how much can we touch? The answer is almost nothing. When you do the geometry carefully, accounting for the way the expanding universe distorts distances and volumes, you find that the reachable region is only about 3% of the observable universe. 3%. For every 100 galaxies we can see, 97 of them are already beyond any signal we could ever send. We could launch a fleet of ships at the speed of light in every direction, starting today, never stopping, and across the entire future history of the cosmos. Those ships would only ever be able to visit about one galaxy in 30 of the ones currently shining in our telescopes. The other 29 out of 30 are visible and unreachable postcards from places we are forbidden to go. I want to slow down here, because that number deserves to be felt rather than just heard. Picture the deepest image ever taken by our telescopes, that single grain of sand patch of sky crowded with thousands of galaxies. Now imagine reaching out and dimming almost all of them, leaving only a scattered handful glowing, perhaps 30 or 40 out of the thousands. That handful is the reachable universe. Everything else in the frame, every other spiral and smudge and faint red ember, is a place we can study, but never enter. And this is not because our rockets are too slow or our lifespans too short. It would be true for any civilization, anywhere, with any technology permitted by physics, traveling at the absolute limit of speed. 97% of what they can see is already gone, and it is getting worse, second by second, in a way that is genuinely happening as you listen. The reachable territory is not a fixed 3%, it is shrinking. The accelerating expansion is continuously carrying galaxies across the event horizon, out of the touchable region, and into the permanently lost. Every moment, somewhere around the edge of our reachable map, a galaxy makes its final crossing. Its present self slips beyond the horizon, and from that instant, no message we ever send can reach it. It happens constantly, quietly, without any signal to mark it, like a slow tide going out and never coming back in. The pocket of reachable cosmos we inhabit is contracting around us, not because we are doing anything wrong, but simply because of what space is and what it does. That phrase, the pocket of reachable cosmos, is worth holding on to, because by the end of tonight, we are going to watch it shrink all the way down to something almost unbearably small. But for now, let us understand the strange mechanics of the shrinking, because they are not what most people expect. You might imagine that as the universe expands, our horizons would push outward, that we would see and reach more and more as time goes on. And for the seeing, that is partly true. The observable universe does slowly grow as more distant light has time to arrive. But for the reaching, the opposite happens. The faster the expansion accelerates, the more aggressively it carries distant galaxies out of contact, and so the reachable region tightens even as the visible region creeps wider. We are gaining the ability to see slightly farther while losing the ability to touch almost everything. The gap between sight and contact widens with every passing age. There is a way of stating this that I find genuinely difficult to absorb, even having thought about it for a long time. In the entire future history of the universe, no matter how long civilizations endure, no matter how far they spread, the total number of galaxies any of us will ever be able to reach was essentially fixed long ago, and it is a tiny fraction of what exists, and that fraction is only ever going to get smaller. We are not at the beginning of an age of expansion into the cosmos. In the sense that matters most, the sense of what we can ever actually get to, we are already near the end of one. The doors were closing before we evolved eyes to notice them. Most of the universe was lost to us before the first human looked up. Now, I have been careful all along to keep something true in view, and I want to return to it here, because this is exactly the moment it matters. The universe is not pushing us away out of malice. There is no force singling us out, no cosmic intention behind the closing doors. The galaxies crossing the horizon are not fleeing us. They feel no repulsion, obey no command to leave. Each one simply sits in its own region of space, while the space everywhere swells, and the swelling carries it off. If you could stand in one of those departing galaxies, you would not feel yourself moving at all. You would look back at the Milky Way and see it receding from you, redshifting, slipping toward your own horizon, and you would feel, with perfect justification, that you were the still point and we were the ones being carried away. The exile is mutual and it is impersonal. It is the most even-handed thing the universe does. It does it to everyone, everywhere, in exactly the same way. I find a strange comfort in that, and I think you might too, once the first chill of the numbers passes. The loneliness the universe imposes is not a punishment and not a rejection. It is not aimed. It is simply the shape of living in a place where space grows. Every observer who has ever existed around every star in every galaxy has been or will be sealed into their own shrinking pocket by exactly the same process. We are not the unlucky ones. We are not cursed. We are ordinary citizens of an expanding cosmos, learning what every citizen of such a cosmos eventually learns. There is something almost democratic about it. The horizon does not check who you are before it closes. But understanding that the closing is impersonal does not tell us why it is happening at all. We have described the expansion and the acceleration and the horizons they produce, but we have not yet named the cause. What is it that pushes the galaxies apart faster and faster? What overpowers the gravity of 2 trillion galaxies, all of it pulling inward, and instead drives everything outward at an ever-increasing pace? For most of the 20th century, no one even suspected such a thing existed. The assumption, the safe and sensible assumption, was that gravity must be slowing the expansion down, that the cosmos was a thrown ball, gradually losing its upward speed. The discovery that the ball was instead accelerating away, climbing faster the higher it rose, was so unexpected that the people who found it spent months convinced they had made a mistake. They had not made a mistake. They had found the thing that fills the universe and drives it apart. The substance that makes up more than 2/3 of everything that exists and yet emits no light, has no clumps, sits in no galaxies, and reveals itself only through the accelerating retreat of the cosmos. They had found dark energy. And the night they found it, looking at the dim light of exploding stars billions of years old, is one of the strangest and most human moments in the history of science. A moment when 2 rival teams of astronomers, racing each other, both arrived at a conclusion neither of them wanted to believe. Let us go to that night and meet the thing that is sealing us in. Part 6. The night we learned the universe was speeding up. In the late 1990s, 2 teams of astronomers were racing to measure how fast the expansion of the universe was slowing down. Notice the assumption buried in that sentence. They were not asking whether it was slowing down. Everyone knew it must be. The only question worth a career was how much. The universe was full of matter. Matter has gravity, and gravity pulls inward, so the expansion that began with the Big Bang had to be losing speed, decade by decade, eon by eon, dragged back by the collective pull of everything in it. The teams wanted to measure the rate of that slowing, because the rate would tell them the ultimate fate of the cosmos. Slow enough, and the universe would expand forever. Coasting, fast enough, and gravity would someday win, halt the expansion, and pull everything back together into a final collapse. It was one of the great open questions, and it seemed answerable. To answer it, they needed a way to measure enormous distances across the universe with precision, and they found one in a particular kind of exploding star. When a certain type of dead star, a white dwarf, draws too much matter onto itself, it detonates in a blast called a Type 1a supernova, and these explosions are extraordinarily useful because they all peak at very nearly the same true brightness. They are standard candles. If you know how bright a thing truly is, and you measure how bright it appears, you can calculate how far away it must be, the same way you could judge the distance of a candle in the dark if you knew exactly how strong its flame was. By finding these supernovae in distant galaxies, and measuring both their apparent brightness and their redshift, the teams could chart how the expansion had behaved over billions of years. One team was the Supernova Cosmology Project, led by Saul Perlmutter. The other was the High Z Supernova Search Team, with Brian Schmidt and a young astronomer named Adam Rees doing much of the analysis. They worked separately, checking each other through competition, each hoping to be first to pin down the deceleration of the universe. And as their data came in, both teams found the same impossible thing. Picture the moment. Adam Rees is sitting with the numbers, the measured distances to these far-off exploding stars plotted against their redshifts, against the model of a universe that should be slowing down. And the supernovae are in the wrong place. They are too faint. Too faint means too far. The distant explosions are farther away than a decelerating universe could put them, farther than a coasting universe could put them. The only way to fit the data is to say that the expansion was slower in the past and has been speeding up ever since, that the universe is not losing speed against gravity, but gaining it, climbing faster the higher it rises, as if the thrown ball, instead of falling back, were accelerating up into the sky. Rias assumes he has made an error. He checks it. He looks for the mistake in the analysis, the contamination in the data, the overlooked correction. It does not go away. He sits with a result that says the universe is being pushed apart by something nobody has ever measured, something that fills empty space and drives the cosmos to expand faster and faster, and he cannot make the result disappear no matter how he turns it. On the other side of the competition, Perlmutter's team is staring at the same conclusion, equally unwilling, equally unable to escape it. Two rival groups, hoping to measure a slowing, both forced by their own data to announce a speeding up. When independent rivals, who would love to prove each other wrong, are dragged to the identical, unwelcome answer, you are usually looking at the truth. The truth was that more than 2/3 of the universe is made of something that has no name except a confession of ignorance. We call it dark energy, and the word dark here does not mean black or sinister. It means hidden, unknown, unaccounted for. Dark energy is the name we give to whatever it is that fills all of space with a faint, relentless outward pressure, a tendency for space to expand that grows more dominant as the universe gets larger. When you measure the total contents of the cosmos, you find that ordinary matter, the stuff of stars and planets and people, makes up less than 5%. Dark matter, a different mystery, makes up about 27%. And the remaining 68 or 69%, the great majority of everything, is dark energy. The universe is mostly made of the thing that is driving it apart. The three astronomers who led that discovery, Perlmutter, Schmidt, and Rees, shared the Nobel Prize in Physics in 2011 for it. Here is what makes dark energy so different from everything else, and so decisive for our isolation. Ordinary matter dilutes as the universe expands. Spread the same amount of stuff through a larger volume, and it thins out. Its density drops, its gravity weakens. So if the universe contained only matter, the expansion would indeed slow, because the inward pull, though weakening, would always act as a brake. But dark energy does not dilute. As best we can measure, it has the same density everywhere, always. And crucially, it keeps that same density even as space grows. Make twice as much space, and you get twice as much dark energy to fill it, pushing twice as hard. This is the signature of what physicists call a cosmological constant, an energy that belongs to space itself, intrinsic to the vacuum, undiminished by expansion. And because it does not weaken while matter does, dark energy was destined to win. In the early universe, packed and dense, matter's gravity dominated and the expansion slowed. But as space grew and matter thinned, there came a crossover a few billion years ago when dark energy overtook gravity and the expansion began to accelerate. We live on the far side of that crossover, in the age of dark energy, when the outward push has taken permanent control. And now the horizons we talked about make a darker kind of sense. If the expansion were merely coasting, the situation would be serious but not final. But because the expansion accelerates, because dark energy keeps pushing harder as the universe grows, the recession of distant galaxies speeds up without limit, and the event horizon becomes a true and permanent wall. In a universe that only coasted, a patient enough signal might eventually reach almost anywhere. In a universe that accelerates, Enormous regions are sealed off forever, and more are being sealed off all the time. Dark energy is not just the thing that expands the universe. It is the thing that locks the doors behind us as the universe expands. It is the jailer, and the jailer is not a person or a force with a purpose. It is a number, a property of empty space, an energy density so faint that in any room you have ever stood in its total effect is utterly negligible, and yet so pervasive, filling every cubic inch of the immense space between galaxies, that, across cosmic distances, it overrules all the gravity of all the matter that exists. There is something almost vertiginous about the smallness of the moment against the size of the conclusion. A handful of people, looking at a few dozen smudges of light from stars that exploded before the Earth was born, discovered that the entire universe is running away from itself faster and faster, and that the long-term future of everything is deepening separation. They were not trying to find that. They wanted a tidy number for the slowing. Instead, they found the engine of cosmic loneliness, and they found it almost by accident, the way you might reach for a familiar thing in the dark and touch something you cannot identify. We have now named the hand that closes the horizon. In the next part, let us understand the shape of the cage it builds, a shape that turns out to be one of the most beautiful and unsettling ideas in physics, a black hole turned completely inside out. Part 7. The Black Hole Turned Inside Out. You already have an intuition for what a horizon in space can do, even if you have never thought of it this way, because you have heard of black holes. A black hole has a surface called an event horizon, a boundary in space with a brutal one-way rule. Cross it going in, and you can never come back out. Light itself, falling past that surface, cannot climb back. The horizon is not a wall you crash into. It is a place where the geometry of space and time tilts so steeply that every possible path leads inward and outward, simply stops being a direction you can go. Anything that crosses it is lost to the outside universe forever. Now turn that picture inside out, and you have the situation we live in. The cosmic event horizon created by dark energy is, in a precise mathematical sense, a black hole horizon reversed. With a black hole, you are outside, and the horizon surrounds a region you cannot get into. With the cosmic horizon, you are inside, and the horizon surrounds a region you cannot get out of. It encloses you. Everything within it is, for now, your reachable world. Everything beyond it is gone. And just as nothing can climb out of a black hole, nothing within our cosmic horizon can ever send a signal to what lies beyond it, and nothing beyond it can ever send a signal in. The two sides are causally severed, sealed off from each other, as completely as the inside and outside of a black hole. We are not falling into the horizon. We are living inside it, in a bubble of reachable space, while the rest of the universe streams outward across the boundary and is lost. Physicists have a name for the kind of universe we are heading toward, a universe whose expansion is dominated entirely by a cosmological constant. They call it de Sitter space, after the Dutch astronomer Willem de Sitter, who worked out its mathematics not long after Einstein gave us the equations of gravity. De Sitter space is the pure form of what dark energy is turning our cosmos into, an exponentially expanding emptiness with a fixed horizon around every observer. As dark energy comes to dominate more and more completely, our universe is settling, over billions of years, into a de Sitter state. And in that state, the horizon stops shrinking in our terms and settles at a fixed distance, a permanent boundary about 16 billion light-years out, the same for every observer, an inescapable feature of the geometry. Each point in such a universe sits at the center of its own horizon, its own sealed bubble, its own pocket of reachable space, and no two bubbles that drift apart can ever exchange a word again. Here is where the analogy to a black hole becomes more than a poetic flourish, because it turns out the resemblance runs deeper than anyone expected. In the 1970s, physicists discovered something astonishing about black hole horizons. They are not perfectly black. Stephen Hawking showed that the event horizon of a black hole, through subtle quantum effects, must glow faintly, radiating a feeble warmth, having a temperature. A black hole is not just a hole. It is, in the strange accounting of quantum physics, a warm object radiating very slowly into the dark. And shortly after, Hawking, working with Gary Gibbons, showed that the same logic applies to the cosmic horizon of a de Sitter universe. Our cosmic event horizon, the boundary that seals us in, should also glow. It should have a temperature. The horizon of the universe is faintly warm. The warmth is almost incomprehensibly slight. The temperature of our cosmic horizon is something like 10 to the minus 30th of a degree above absolute zero, a number so close to nothing that it has no practical effect on anything, a whisper of heat so faint that it would take longer than the current age of the universe many times over to matter at all. But the fact that it exists at all is staggering. It means the boundary of our reachable world is not just an abstract line in the mathematics. It is a physical surface with physical properties, a thing that has a temperature, a thing that radiates, in the same family as the horizon of a black hole. We are sealed inside a warm-walled bubble, and the wall is woven from the same quantum threads as the most extreme objects in the cosmos. The cage is not metaphorical. It is as real as anything in physics, and it even glows. Let me try to give you the feel of this, because the mathematics can hide how strange it is. Imagine that you could somehow see the cosmic horizon, render it visible, the way you might imagine seeing the surface of a black hole. You would find yourself at the center of an enormous sphere, 16 billion light-years in radius, its surface impossibly distant and yet absolutely impassable. Within the sphere, galaxies drift, some of them slowly making their way toward the edge. And as a galaxy approaches that surface, something eerie happens to how it appears to you. Its light reddens and dims. Its motion seems to slow. Time, from your vantage, appears to stretch out for it, the way time appears to freeze for anything falling toward a black hole. The galaxy seems to take longer and longer to reach the boundary, fading and reddening as it goes, never quite seen to cross, its final image lingering and stretching toward an endless, dimming red. It does not wink out. It draws out into a long, slow, reddening farewell that, in principle, never quite finishes, even as the galaxy itself has long since passed beyond and gone. That is the view from inside the cage. Galaxies slipping toward a glowing wall, reddening as they go, their goodbyes stretched across eternity by the geometry of expanding space. And it is happening right now, all around us, to the most distant galaxies in our sky. Some of the faint red smudges in our deepest images are objects in the long act of crossing, their light stretched toward invisibility by the swelling of the space they crossed. We are watching the universe leave, in extreme slow motion, in a fade so gradual that across a human lifetime nothing seems to change at all, and yet across cosmic time the sky is steadily emptying. I keep calling it a cage, and I want to be careful with that word, because it carries a feeling of cruelty, of something done to a prisoner by a captor. But the cosmic horizon has no captor. It is not built by anyone. It is the natural consequence of a positive energy in empty space, an automatic feature of the geometry as impersonal as the horizon of the Earth that hides the ships sailing over it. The Earth's horizon is not hiding the ships from you out of spite. It is just the curve of the world. The cosmic horizon is just the curve of an expanding universe. It hides the galaxies the way the round Earth hides the sea beyond a certain distance, except that this curve, unlike the Earth's, cannot be crossed by sailing farther, because the more you sail, the more the curve runs ahead of you. So we live inside an inside-out black hole, a warm-walled bubble of reachable space, sealed by the geometry of a universe that dark energy is driving toward the pure emptiness of de Sitter space. We have named the force dark energy, and we have seen the shape of the prison it builds, a glowing horizon at 16 billion light-years. But there is one more thing we have only described from the outside, and to truly understand it, we have to go inside it. We have to ride along with a beam of light, one of those doomed photons, setting out across the swelling dark toward a galaxy it will never reach, and feel for ourselves what it is to travel as fast as anything can travel and still lose ground forever. Let us become that light. Part 8. The light that never arrives. Close your eyes, if you are somewhere you can, and come with me to the edge of the reachable universe. We are going to become a single particle of light, one photon, setting out on a journey across the swelling dark, not from Earth this time. Let us begin our journey out there, in a galaxy near the boundary of what we can still reach, and let us aim ourselves homeward, toward the distant pale spiral of the Milky Way, and see what happens when we try to make the crossing. You are born in a flash, in the core of a star in that far galaxy, and in an instant you are flung outward into the night at the only speed you have ever known, the speed of light, 300,000 kilometers every second, the fastest anything is allowed to move. Ahead of you lies your destination, the faint smudge of our galaxy, almost unimaginably far. But you are patient, and you are fast, and you have all the time there is. You set out. The star falls away behind you. The dark opens up ahead. For a while, the journey feels like progress. You cross the empty space between stars, then the emptiness between your home galaxy and its neighbors, and the distance to the Milky Way slowly begins to shrink. You are gaining. The road is long, but you are eating it, mile after mile after mile, 300,000 kilometers with every tick of a clock. If space would only hold still, you would arrive. Distant, yes, but arrival is just a matter of time, and you have time, but the space does not hold still. As you travel, you begin to notice something wrong with the road. The distance ahead of you is not shrinking as fast as it should. You are moving at full speed, the maximum, and yet the Milky Way is not getting closer at the rate your speed promises. New space is appearing in the gap ahead, quietly, everywhere, all along the path between you and your destination. Every kilometer you cross, a fraction of a kilometer, is added back in front of you, born out of the expansion of the universe itself. You are running up a road that is lengthening beneath your feet, and it is getting worse. This is the thing about dark energy, the thing that makes it final rather than merely difficult. The expansion is accelerating. The longer you travel, the faster the new space appears. Early in your journey, the road grew slowly, and you outpaced its growth, and you gained ground. But as the ages pass, as billions of years go by, and you press on toward the pale spiral that never seems to brighten, the growth of the road speeds up, and there comes a moment, somewhere out in the dark, when the road begins to lengthen faster than you can cross it. From that moment on, every second carries the Milky Way farther from you than your own speed brings it closer. You have crossed the event horizon in the only way a photon ever can, and you do not feel a thing, because there is nothing to feel. There is no wall, no barrier, no shudder. There is only the slow, dawning mathematics of a destination that is now receding faster than you approach. Notice what is happening to you, too, as you travel. Your own light is stretching. You were born a particle of golden starlight, a certain crisp wavelength, but the swelling of the space you cross stretches you along with everything else. Your wavelength lengthens. Your gold slides toward orange, toward red, toward a long, slow crimson, and then past the edge of anything an eye could see, into the infrared, into wavelengths longer and longer, your energy draining away into the growing dark. You are not slowing down. A photon never slows. You are still moving at exactly the speed of light, as you always have, as you always will. But you are reddening toward nothing, your color stretched out by the same expansion that lengthens your road, until you are a long, faint, invisible ripple crossing an ocean that grows faster than you swim. And the Milky Way, your destination, the place you set out for so long ago, is no closer than when you began. It is farther. It will always, from now on, be farther. You will travel for billions of years, then trillions, then numbers that have no names, and the pale spiral will recede ahead of you the whole time, dimming and reddening in your view, as you dim and redden in anyone else's, two travelers on a road that grows between them forever, neither one slowing, neither one stopping, never meeting. You are doing everything right. You are moving as fast as the universe permits. And it is not enough, and it will never be enough, because the universe is not a place you cross. It is a place that grows faster than crossing. Open your eyes. Come back to the earth, to the room you are in, to the ordinary night. And understand that this is not a thought experiment about some exotic corner of the cosmos. It is the literal fate of light, right now, all over the sky. At this very moment, photons are setting out from Earth in every direction, and the ones aimed at the 97% of galaxies beyond our horizon are embarking on exactly the journey you just took, a journey with no arrival, a chase with no end. Every beam of light we have ever sent toward the distant universe, every signal, every stray radio whisper from our cities, is out there running a road that grows faster than the light can cross it, bound for galaxies it will never reach. We are shouting into a dark that is widening faster than our voice can travel. There is a particular kind of loneliness in that image, and I do not want to soften it too quickly, because it is true and it deserves to be felt. We are a species that learned to send light across the cosmos, that built telescopes to catch the light of others, that has spent its short history reaching outward with everything it has. And the universe has arranged itself so that almost all of that reaching falls short, not by a little, but absolutely, the reaching swallowed by growing space before it can ever land. We can see the others. We can study them, love them from a distance, learn their stories from the ancient light they sent, but we cannot answer. The line is one way, and the dark is widening, and our brightest signal, like our doomed photon, will run forever and never arrive. And yet, even here, the old reassurance holds, and I think it is worth holding on to as we go deeper. The universe is not pushing our light away out of malice. There is no hand on the photon, no force deflecting it, no cosmic refusal. The light fails to arrive for the gentlest of reasons, because space is generous, because it keeps making more of itself, because the universe is the kind of place that grows. The very property that fills the cosmos with room, that gives the galaxies their space to form and turn and shine, is the property that strands us. The expansion that isolates us is the same expansion that made the roominess in which everything we love came to exist. We are not being denied. We are simply living in a universe whose openness is also its loneliness, where the same swelling that gave us a place to be also keeps us from reaching anyone else. We have ridden the doomed light to its endless road and felt the seal of the horizon from the inside. Now let us do the hardest and most beautiful thing this topic asks of us. Let us go forward in time, far forward, past the age of galaxies, and see what this universe of widening dark finally becomes, and what it does to the ones who will live there, in the last lit island, in an emptied sky. Part 9. The Last Galaxy. Let us travel 100 billion years into the future. The number is so large it resists meaning, so let me anchor it. The universe today is about 13.8 billion years old. We are going to a time roughly 7 times older than the entire present age of the cosmos, a future so distant that the universe of today, with all its visible galaxies, will seem like a brief, bright morning long since past. And we are going to find out what the accelerating expansion finally makes of everything. First, the good news, because there is some, and it matters. Not everything gets carried away. The expansion of the universe only wins where gravity is too weak to resist it, out in the great gulfs between galaxies and clusters of galaxies, where matter is spread thin. But in places where gravity is strong, where matter has already gathered itself into a bound knot, the expansion cannot pull it apart. Our own galaxy will not be torn open by dark energy. The solar system will not be stretched. The atoms in your body will not be pulled loose. Anything held together tightly enough by gravity or by the other forces of nature simply stays together, an island of stable structure in a universe whose empty spaces grow without end. The Milky Way belongs to a small bound family of galaxies called the local group, a few dozen galaxies held together by their mutual gravity, dominated by ourselves and our large neighbor, the Andromeda Galaxy. These galaxies are close enough and heavy enough that gravity, not expansion, controls their relationship, and so they are not receding from each other, they are falling together. Andromeda is approaching us, and in a few billion years, our two galaxies will collide and merge, their stars sweeping past one another, their structures churning and settling over a long age into a single enormous elliptical galaxy. Other members of the local group will fall in too, joining the merger until the whole bound family has become one great island of stars. This merged galaxy will be the home of whatever lives in our cosmic neighborhood in the far future. It is, in a sense, the last galaxy that will ever matter to us, the final shape of everything gravity has managed to hold on to against the widening dark. Now look outward from that future island and feel what has happened to the rest of the universe. Every other galaxy, every galaxy not bound into our local group, has been carried away by the accelerating expansion. Across those 100 billion years, the relentless growth of space has pushed them all beyond the cosmic event horizon, one after another, their light reddening and dimming and finally stretching out past the possibility of detection. The sky that we know, crowded with 2 trillion galaxies, will have emptied. The galaxies will not have been destroyed. They will still be out there, shining, full of stars, going about their existence. But they will be gone from any possible contact and, worse, gone from any possible sight. Their light, stretched by the expansion across all that distance and time, will have faded below anything any telescope could ever gather. The pocket of reachable cosmos, which today holds 3% of a visible universe, will have contracted to a single galaxy, one. The merged island, alone in a darkness that yields nothing. The physicists Lawrence Krauss and Robert Scherer described this future in a memorable way. They called it the return of a static universe and the end of cosmology. The phrase is worth unpacking because it contains the real horror and the real poignancy of where we are headed. By cosmology, they mean the science of the universe as a whole, the study of its size and age and origin and fate. And they argue that this science has an expiration date. The reason we know the universe is expanding, the reason we know it had a beginning, the reason we know about the Big Bang at all, is that we can see other galaxies and measure their redshifts, and we can detect the faint afterglow of the universe's hot birth, the cosmic microwave background, the radiation left over from the first few 100,000 years. All of that evidence, every shred of it, depends on being able to see beyond our own galaxy. And in that far future, none of it can be seen. The other galaxies are gone beyond the horizon, so there are no redshifts to measure, no expansion to detect. The cosmic microwave background, that ancient afterglow, will itself have been stretched by the expansion until its wavelengths are longer than the observable universe can contain, redshifted into undetectability, erased. The evidence of the Big Bang will have been swept out of reach, along with everything else. A scientist living in that merged island galaxy, no matter how brilliant, no matter how powerful their instruments, will look out and find nothing beyond their own stars. No other galaxies, no background glow, no sign that space is expanding, no trace of a beginning. Sit with what that means. The universe is, slowly and certainly, erasing the evidence of its own history. The clues that let us reconstruct the Big Bang, the expansion, the existence of a cosmos beyond our galaxy, are not permanent features written into the sky forever. They are temporary. They are visible now, in our era, and they are being carried away, and there will come a time when they are simply gone, when the truth of the universe's birth and growth has been placed permanently beyond the reach of anyone who might want to know it. The cosmos is not just isolating us in space, it is isolating the future from the past, sealing away the record of where everything came from, closing the book on its own origin. There is a thought hidden in this that I find almost too large to hold, and I want to offer it to you gently, because it changes how you see our own moment. We tend to assume that the future will always know more than the past, that knowledge accumulates, that a sufficiently advanced civilization could, in principle, figure out anything about the universe, given enough time and cleverness. But that is not true. Some truths have a window, and the window closes. The fact that the universe began in a hot, dense state and has been expanding ever since is a truth that can be known now and will not be knowable then. We are not living in the era of greatest possible knowledge that we naively imagine the future to be. In at least one enormous respect, we are living in a privileged moment, an age when the universe is still legible, still telling its own story in light, before the long silence sets in and the evidence drifts beyond the horizon for good. The future astronomer in that last galaxy will not be ignorant. They will not be foolish. They will study their single island of stars with great care, and they will reach a confident, careful, internally consistent conclusion about the nature of the universe. And the conclusion they reach, reasoning correctly from everything they can see, will be utterly and completely wrong. That is the part we have to face next, because it is not only a fact about the far future, it is a warning, pointed straight at us, about the trustworthiness of our own sky. Part 10. The Astronomer Who Will Be Wrong. Stand with me now on a world in that last galaxy, 100 billion years from now, and look up. I want you to really be there for a moment, because the whole meaning of tonight turns on what you see, and on the chilling fact that you cannot tell, from inside, that anything is missing. The night sky above you is full of stars, your own galaxy's stars, the merged remnant of everything gravity once held together, a great wheel of light turning slowly overhead. It is beautiful. It is, in fact, all the sky you have ever known, all the sky anyone here has ever known, for as far back as your civilization's records go. And beyond the stars, where we would see the faint smudges of other galaxies, where our telescopes today find thousands of distant island universes crowding every dark patch, you see nothing, not darkness with hidden depths, not a sky full of faint things just beyond your instruments. You see a clean, absolute, featureless black, and your most sensitive instruments confirm it. There is nothing out there. There has never, in all your observations, been anything out there. The universe, as far as you can possibly tell, is a single galaxy of stars surrounded by infinite empty void. So you do what any good scientist would do. You build a model of the universe that fits what you observe. And the model practically writes itself. There is one galaxy, your own. It is not expanding, because there is nothing outside it to expand into and nothing to measure expansion against, no distant objects whose recession could reveal it. There is no afterglow of any beginning, no leftover radiation from a hot, dense birth, because that radiation has long since been stretched away beyond detection. The galaxy appears to be static, eternal, unchanging on the largest scale. You conclude, with excellent evidence and rigorous reasoning, that you live in a single eternal island of stars in an infinite static void, a universe with no beginning and no expansion and no edge. And you are wrong. You are completely, profoundly wrong about nearly everything that is true of the cosmos. And there is no experiment you could ever perform, no instrument you could ever build that would reveal your error. The evidence that would correct you has been carried beyond your horizon and erased. Those of you who have travelled with me before into the strange story of the boat's void and the great emptiness at the centre of the cosmic web will recognise this trap because we have stood at its edge once already. There we imagined a civilization that evolved near the middle of an enormous empty region of space, a region so enormous that they could see almost no other galaxies, and we saw how they too would reason correctly toward a falsely small universe, concluding their lone galaxy was all there was. That was an illusion caused by location, by the accident of being born in an unusually empty pocket of space. What we are facing now is the same illusion caused by time. The future astronomer is not in a special place. They are in a special era, an era after the expansion has carried everything else away, and the result is identical. An observer of flawless competence, reasoning impeccably from complete and honest evidence, arrives at a confident picture of the universe that is simply false, because the truth has been placed beyond their reach. Now, turn that around and point it at yourself, because this is the moment the whole topic stops being about the far future and becomes about us. We trust our sky. We look out at the galaxies and the cosmic background and the measured expansion, and we build our model of the universe from them, and we believe, reasonably, that our model is true because it fits everything we can see. But the future astronomer believes exactly the same thing about their model, with exactly the same justification, and they are wrong. So the unsettling question lands on us with its full weight. How do we know we are not in their position already? How do we know that the universe has not already carried some crucial part of itself beyond our horizon, leaving us, like them, to reason confidently toward a picture that is missing its most important pieces? We cannot know. By the very nature of a horizon, what lies beyond it leaves no mark we can read. We may be the lucky ones, living early, while the evidence still arrives. Or we may already be living in a partial sky, a sky that has quietly lost something we will never know we lost. You can see it, but you can never touch it. I told you that sentence would come back, and here it is, changed. When we first met it, it was about distance, about galaxies we can observe but never reach. But the future astronomer shows us its deeper form. They can see their universe, can observe it with perfect clarity, can build a flawless picture of everything in front of them, and they can never touch the one truth that would correct them, the truth that there is more, that it is expanding, that it began. The thing they cannot reach is not a galaxy. It is knowledge itself. The horizon does not only seal away places, it seals away facts. It hides not just where things are, but what is true, and it hides them so thoroughly that the deceived observer cannot even suspect the deception. You can see it, you can never touch it, and the it, in the end, is the truth of your own universe. There is a grief in this that is different from the grief of mere distance, and I think it is the deepest note in the whole subject. It is one thing to be unable to reach the other galaxies. It is another to know that the universe is in the business of forgetting itself, of erasing its own origins, of arranging things so that its children, in the long run, cannot learn where they came from. The cosmos is not preserving its history for whoever comes later. It is letting that history slip away over the horizon, quietly, permanently, until the record is gone, and only a beautiful, misleading silence remains. We happen to live in the narrow window when the record is still legible. That is not a small thing. That is, perhaps, the the most precious accident of our existence, that we arrived early enough to read the universe before it finished closing the book. And so, I want to offer you a way to feel this, that is not only sorrow, because there is another side to it. We are not the deprived ones in this story. We are the privileged ones. Of all the observers who will ever exist in this universe, across all of the immense future, we are among the tiny minority who get to see the whole truth, who live in the brief lit era when the other galaxies still shine in our telescopes, and the afterglow of the beginning still washes faintly across our sky, and the expansion still reveals itself in the stretched light of distant things. The future is darker and lonelier and more ignorant than the present. The galaxies are leaving, and the evidence is fading, and the long silence is coming. But it is not here yet. We got here in time. We are the generation that can still look up and see the company we are losing, still read the universe's story before it is carried away. And there is something almost sacred in that timing, in having opened our eyes during the one age, when the cosmos was still willing to tell us where we came from. We have followed the isolation all the way to its end, to the last galaxy and the deceived astronomer and the erased origin. But we have not yet asked the strangest question of all, the question that turns this from a sad story about expansion into something that has unsettled physicists in a far more personal way. Why is the universe like this at all? Why does dark energy have the particular strength it has, the strength that seals us in? Because that number, it turns out, is not just any number. It sits in a place so peculiar, so finely balanced, that some of the most serious people in physics have found themselves staring at it and wondering whether it could possibly be an accident. Let us ask, at last, whether any of this is by design. Part 11. The number that should not be. Here is the fact that turns a story about cosmic loneliness into something that keeps physicists awake. The strength of dark energy, the number that decides how hard space pushes itself apart, is not just unexplained. It is unexplained in a way that is almost offensive to anyone who looks at it closely. It sits at a value that, according to our best theories, it has no business having, and the size of the discrepancy is the largest and most embarrassing mismatch between theory and observation in the entire history of science. Let me walk you through why. Dark energy behaves like an energy that belongs to empty space itself, to the vacuum. And we have a theory of the vacuum. Quantum physics tells us that empty space is not truly empty. It seethes with activity, with particles flickering in and out of existence, with fields humming at every point, with what physicists call vacuum energy. So we can ask our theories a simple question. How much energy should empty space contain? How strong should the dark energy be if it comes from the quantum vacuum? And quantum field theory gives an answer. The answer is enormous. The naive calculation says the vacuum should be packed with energy at a density so high that it would have ripped the universe apart in the first instant, expanding it so violently and so fast that no galaxy, no star, no atom could ever have formed. The predicted dark energy is too strong by a factor that staggers the imagination. How much too strong? The theoretical prediction overshoots the measured value of dark energy by roughly a factor of 10, followed by 120 zeros. Let me try to convey that number, because no one can feel it stated plainly. A factor of 10, with 120 zeros after it, is not the kind of error you make in an arithmetic problem. It is not being off by 1,000, or 1,000,000, or 1,000,000,000. The number of atoms in the entire observable universe is something like 10, with 80 zeros after it. So the mismatch between what theory predicts for dark energy and what we actually measure is enormously larger than the number of atoms in all the galaxies we can see, larger than almost any quantity that appears anywhere in physics. Physicists call this the cosmological constant problem, and they say, with no exaggeration, that it is the worst theoretical prediction in the history of physics. Our best theory of the vacuum, asked to predict the one number that governs our cosmic fate, gives an answer that is wrong by more than 120 orders of magnitude. And here is the truly strange part. If the prediction were right, we would not be here. If dark energy were anywhere near as strong as the theory says it should be, the universe would have flown apart so fast and so early that matter could never have gathered into galaxies and stars. There would be no structures, no chemistry, no planets, no life. The only reason the cosmos held together long enough to make anything at all is that dark energy is, against all theoretical expectation, almost incomprehensibly weak enough to let gravity build galaxies for billions of years before the expansion finally took over. The number that seals us in, the number that makes the universe accelerate and isolates every observer, is also a number tuned so finely toward weakness that any substantially larger value would have meant a barren, structureless, lifeless cosmos in which no one could ever have existed to feel lonely. This is where the phrase from our title earns its weight. The universe seems designed to keep us alone. And the seeming is sharp here, because the very quantity responsible for our isolation appears to be balanced on a knife's edge, set to a value in the narrow window that permits existence. Slightly stronger, and there would be no galaxies, no us, no isolation, because there would be no one to isolate. Slightly weaker or negative, and the universe might have collapsed back on itself long ago. The dark energy that strands us is the same dark energy that, by being so improbably gentle, allowed everything we are to come into being. The hand that locks the door is the hand that built the house. There is a famous moment in this story that shows how seriously the best physicists take it. In 1987, more than a decade before dark energy was discovered, the physicist Steven Weinberg, one of the great minds of the 20th century, made an argument that sounds almost like prophecy in hindsight. He reasoned that if there were some explanation for the strength of dark energy that involved the existence of observers, then dark energy could not be too strong, because a universe with strong dark energy would have no galaxies and therefore no observers to measure it. So he predicted that if dark energy existed at all, its value should be small, but probably not zero, sitting just inside the range that still permits galaxies to form. He calculated, roughly, where that boundary should be. And when the discovery came, in 1998, the measured strength of dark energy landed close to where Weinberg's reasoning said it should, small, positive, near the edge of the window that allows structure to exist. A prediction made from nothing but the requirement that observers be possible turned out to point at the right answer years before anyone measured it. That is the kind of thing that makes a careful scientist deeply uneasy in the most productive way, because there are only a few ways to read it, and none of them is comfortable. Either the value of dark energy is a staggering coincidence, a number that just happens, by luck, beyond luck, to fall in the one narrow band that permits a universe like ours. Or there is something about the existence of observers that genuinely shapes which value we find, which seems to turn physics on its head. Or there is a deeper law, undiscovered, that fixes the value for reasons we have not yet grasped, a law that would make the apparent fine-tuning not luck at all, but necessity. We do not know which. We genuinely, honestly do not know, and the not knowing is not a gap that better instruments will obviously fill. It may be one of those questions that sits at the very edge of what physics can address. I want to be careful here, because this is exactly the kind of place where wonder can slide into wishful thinking, and the channel does not do that. The fine-tuning of dark energy is real. It is openly discussed in the most serious journals and by the most rigorous physicists. It is not a secret, not a suppressed embarrassment, not a thing scientists are hiding, but the fine-tuning, by itself, is not proof of a designer, and it is not proof of purpose, and anyone who tells you it settles, the question of why we are here is reaching past what the evidence supports. What it is honestly, is a genuine and unsolved puzzle, one of the deepest open questions in physics, the question of why the number that governs our fate has the value it does. The universe seems designed to keep us alone. The word seems is carrying the entire honest uncertainty of modern cosmology, and we are not going to pretend it away in either direction. So we are left holding a coincidence almost too pointed to ignore. The thing isolating us is the thing physics understands least, off from theory by more than 120 orders of magnitude, and tuned, by some means we cannot name, to exactly the gentle value that both permits our existence and guarantees our separation. In the next part, let us look squarely at the possible answers, the three serious roads physicists have laid out, and let us be honest about the fact that we cannot yet tell which of them, if any, is the truth. Part 12. 3 Answers and an Honest Silence. Let us lay out the 3 serious answers to the question of why dark energy has the value it does, the value that both makes us possible and seals us in. I will give each one its fair hearing, and then I will tell you the honest truth, which is that we cannot yet choose between them, and that the inability to choose is itself one of the most interesting facts about our situation. The first answer is the simplest and the hardest to accept. It is coincidence. The value of dark energy is what it is, for no reason, and the fact that it happens to fall in the narrow window that permits galaxies and observers is simply luck, the kind of luck that has to hold somewhere if it holds anywhere. On this view, there is no mystery to solve, only a number to measure, and we measured it, and it is small, and that is the end of the story. The trouble with this answer is not that it is impossible, but that it feels like a refusal to explain. A discrepancy of 120 orders of magnitude, landing precisely in the life-permitting band, asks for an account, and shrugging and calling it luck strikes many physicists as giving up rather than answering. But it might be true. The universe is under no obligation to be explicable, and sometimes a number is just a number. The second answer is the one most cosmologists take most seriously, and it is strange enough that it took the field decades to embrace it. It is the multiverse, combined with a selection effect. The idea is that our universe is not the only one, that there is some larger reality, perhaps an eternally inflating space budding off countless separate universes, or a range of possibilities allowed by deeper physics, in which the strength of dark energy takes a different value in each. In most of those universes, dark energy is strong, as the naive theory predicts, and those universes fly apart instantly and make nothing and contain no one. In a tiny minority, by chance, dark energy is weak, and galaxies form, and stars ignite, and observers eventually arise, and here is the key move. Observers can only ever find themselves in the universes that permit observers. We could not possibly have measured a strong value for dark energy, because a universe with strong dark energy would have no us to do the measuring. So, of course, we find a weak value. We find a weak value for the same reason that a fish, asked to describe its world, will always describe water. The conditions we observe are filtered by the requirement that we exist to observe them. On this view, the fine-tuning is not luck and not design, it is selection. Out of countless universes with every possible value, we necessarily inhabit one of the rare ones that allowed us, and so the apparent tuning is exactly what we should expect to see. It is a powerful answer. Its weakness is that the other universes are, by their nature, beyond our horizon, in the most absolute sense, unobservable, perhaps forever, which leaves the whole idea hovering at the edge of what science can test. The third answer is the hope of many physicists, even if it remains a hope. It is that there is a deeper law, not yet discovered, that fixes the value of dark energy for reasons we do not yet understand, a piece of physics that would show that the number could not have been otherwise, that what looks like fine-tuning is actually necessity in disguise. On this view, the cosmological constant problem is not telling us that we got lucky or that there are many worlds. It is telling us that our current theories are incomplete, that we are missing something, and that when we finally understand the vacuum properly, the absurd mismatch will resolve, and the value will simply fall out of the equations as the only value it could ever have been. This would be the most satisfying outcome, the one where the universe turns out to be lawful all the way down, and the tuning was an illusion born of our ignorance. But no one has found that law, and it is possible no one ever will. So which is it? Coincidence, selection, or a hidden law? The honest answer is that we do not know, and that we may not know for a very long time, and that it is even possible the question lies beyond what physics can ever settle. I find that I do not want to rush past that admission, because the channel is built on the idea that we don't know can be said with wonder rather than frustration. We are standing at the edge of what is knowable, looking at the single number that governs our cosmic loneliness, and we cannot say why it is what it is. That is not a failure. That is the honest shape of the frontier. Now, before we close, I owe you a few words about the readings of this situation that are not science, because they are out there, and the channel believes in meeting them honestly rather than ignoring them. The most natural one, hearing all of this, is to imagine intention. A universe built to keep us alone sounds like something built, and built things have builders. Some take the fine-tuning of dark energy as evidence of a designer, a cosmos arranged on purpose. I have told you why physics does not support that leap, why the appearance of design is exactly what a selection effect would also produce, why the tuning is a real puzzle but not a proven purpose. The honest position is to hold the wonder without claiming the conclusion. The universe seems designed, seems is not is, and the gap between them is where intellectual honesty lives. There are stranger framings too. Some imagine the cosmic horizon as the edge of a simulation, a render limit beyond which nothing is computed, our isolation, a sign that we live inside a constructed world with a boundary. It is a vivid image, but it explains nothing the physics does not already explain better. The horizon is not a mysterious edge that needs a programmer. It is the precise, calculated consequence of a positive energy in the vacuum, worked out in the mathematics of general relativity decades before anyone dreamed of simulated worlds, its distance computed from a measured expansion rate. And some imagine that scientists are concealing how trapped we are, hiding the cosmic prison from the public. But there is nothing hidden here. Everything I have told you tonight, the horizon, the 3%, the end of cosmology, the deceived future astronomer, all of it was worked out in the open, published in the major journals, written about in popular books by the very physicists who discovered it. The difficulty of our situation is advertised, not suppressed. The universe keeps its own secrets well enough that we do not need anyone to keep them for it. And there is one more thing I have to be honest about, which is that even the permanence of the seal is not entirely beyond question. Everything I have described assumes that dark energy is a true constant, unchanging forever. But there are hints, still tentative and hotly debated, from recent surveys of millions of galaxies, that dark energy might not be perfectly constant, that its strength might be slowly changing over cosmic time. If those hints hold up, and they are far from confirmed, the future could be different from the one I have painted. A weakening dark energy might loosen the seal. A strengthening one might tear the universe apart entirely in a different kind of ending. We are watching, carefully, at the edge of the data, and we do not yet know. Even the prison, it turns out, has an uncertain blueprint, because it is built from the one substance physics understands the least. We have walked the whole length of it now, from the comfortable ocean, to the locked horizon, to the deceived astronomer, to the unexplained number and its 3 uneasy answers. There is only one thing left to do, and it is the most important thing. Let us draw it together and find what there is to feel in a universe that seems designed to keep us alone, and why, in the end, the loneliness is not quite the last word. Part 13. Alone together, all at once. Let me leave you with the thought that I find, after all of this, to be the gentlest and the truest. We began tonight with the ocean we were promised, the universe handed to us in childhood as an endless frontier, ours to cross. We have watched that promise dissolve, horizon by horizon, until we arrived here at a cosmos that shows us trillions of galaxies and lets us reach almost none of them, that erases its own history over time, that seals every observer into a shrinking pocket of reachable space by means of a number no one can explain. It would be easy to end in sorrow, but I do not think sorrow is quite right, and I want to tell you why. Consider what is actually happening right now across the whole universe. Around every star that holds a world, in every galaxy that holds a mind, the same horizon is closing. If there are others out there, and in 2 trillion galaxies it is hard to believe there are not, then they are facing exactly what we are facing. Their skies are emptying too. Their reachable pockets are shrinking too. Their distant galaxies are reddening and slipping away over their own horizons, just as ours are over ours. Every observer who has ever existed or ever will, everywhere in the cosmos, is being sealed into their own bright island by the same patient expansion, at the same cosmic moment, each one alone, and yet all of them alone in precisely the same way, for precisely the same reason. There is a strange companionship in that, a fellowship of the isolated. We are not being singled out. We are sharing the deepest possible thing with every other mind in the universe, the experience of watching the others drift beyond reach. We are alone together, all at once. And here is the reassurance I asked you to carry all the way from the beginning. Return now with everything. There is no will behind the closing horizon, no rejection, no punishment, no captor on the far side of the wall. There is only space, doing the one thing space does, growing gently and endlessly, carrying everything away from everything else, not out of cruelty, but out of a kind of indifferent generosity, the same generosity that made the room for galaxies to form and stars to burn and life to begin. The expansion that isolates us is the expansion that gave us a universe to exist in at all. The loneliness and the gift are the same thing, seen from 2 sides. That is not a tragedy with a villain. It is the shape of reality, impersonal and complete, and there is a kind of peace available in accepting it that is not available in raging against it. Think back to the future astronomer, alone in the last galaxy, reasoning correctly toward a false and empty universe. We are not them, not yet. We arrived early. We live in the lit morning of the cosmos, the brief and precious era when the other galaxies still shine in our telescopes, when the afterglow of the beginning still washes faintly across our sky, when the universe is still willing to tell us, in stretched and ancient light, the story of where everything came from. That window is closing. In the long run, the evidence will drift away, and the sky will empty, and the long silence will come. But it has not come. It is not here. We opened our eyes in time. Of all the moments in the immense life of this universe, we are conscious during one of the few when the whole truth is still readable. And we have used that moment, this brief flicker of legibility, to figure out our own situation, to trace the horizons, to weigh the unexplained number, to understand, more or less, exactly how and why we are alone. That is not nothing. That is, I think, close to the most that beings like us could ever hope to do. And the pocket of reachable cosmos, the shrinking territory we have followed all night as it contracts from a universe to a single galaxy, is not empty either. It still holds, for an unfathomably long time to come, our own galaxy and our near neighbours, hundreds of billions of stars, an ocean of worlds that gravity will keep gathered against the expansion long after everything else has gone. Whatever loneliness the universe imposes on the largest scale, it has left us, within our own bound island, more company than we could explore in 1,000 civilizations. The horizon takes the distant galaxies. It does not take the stars over our heads. The reachable cosmos shrinks, but what remains inside it is still a universe by any human measure, still full of light, still ours. So when you go outside tonight, after this, and you look up at the stars, I want you to hold two things at once, because both are true and neither cancels the other. Out beyond what you can see, the universe is leaving, galaxy by galaxy, carried into a dark that widens faster than any light can cross, sealing us into our bright small island by a number that may also be the reason we exist. And here, within reach, within the warm horizon of everything gravity has kept, the stars are still burning, the galaxy is still turning, the company we were given is still here, and will be here, long after the rest has gone. We are alone in the universe in the largest sense, and we are surrounded by more than we can ever use in the only sense that touches us. Both are true. The cosmos is generous, and the cosmos is lonely, and it is the same generosity and the same loneliness, and we happen to be alive in the one era when we can still see clearly enough to understand the difference. The universe seems designed to keep us alone. We have spent this whole night with that sentence, and now, at the end, I think you can feel what the word seems is doing in it. It is not hiding a known answer. It is holding open an honest uncertainty, the real uncertainty at the edge of physics, about whether our isolation is an accident, or a selection among countless worlds, or a clue to a law we have not yet found, or something else we do not yet have the words for. We do not know. We may never know. But we know enough to sit with the question without fear, to look up at the leaving sky and feel not abandoned but oddly at home in it, citizens of an expanding universe, learning a little earlier than most what it means to live in a cosmos that grows. The galaxies are going. The stars are staying. The number is unexplained. And we are here, now, awake, in time to see all of it. That, in the end, is enough. Rest well, and let the quiet of the leaving sky be a comfort rather than a weight, because the dark out there is not coming for us. It is only making room,